and even in translation, they should be clear and understandable. But we will also discuss this a little bit later. So the last very small question that we also face when we administer questionnaires is the question of test norms. How can we actually decide whether a score is high or is low? Last time we discussed standard normal distribution, and you know that if you have data about a mean and standard deviation of on this scale from some other sample, you can always use those two statistics to interpret any score by converting it to a z-score, which reflects the position of a person on the normal distribution. Unfortunately, psychologists were not very happy with these scores, because these scores are fractional, they're not integer, and also half of them are negative. People who don't like mathematics do not like fractional and negative numbers. As a result, psychologists have came up with some scales that use integer values to make it kind of easier to interpret. You are probably familiar with the IQ scale, where the mean score is 100 and standard deviation is 15. So you can always convert your z-score to a standard scale score by multiplying it. So if you want to convert your z-score to an IQ score, just multiply it by 15 and add 100, and you will get an IQ score. Or t-score used by tests like MMPI with 50 as a mean and 10 as a standard deviation. Some questionnaires like Kettle's test use standard 10. And in different test manuals, you can find different conversion procedures, sometimes nonlinear. But in fact, what is important is that all of these scales are basically different ways to put numbers under the horizontal axis on this distribution. Your distribution does not really change, and you may, when you make those conversions, you may lose some information. You may lose some precision. As a result, if you are applying a questionnaire for research purposes, do not use t-scores or standard 10 or whatever it is. Just use your raw scores or some kind of factor scores. But do not do those conversions because you just lose some information. And also, if you are using someone's data, if you are relying on someone's norms, you need to be very careful because you need to ask a question: is the sample where those norms have been obtained comparable to my sample? The problem is that in many cases, test norms are dependent on many things. Like, for example, is a test being administered on paper or online? This can affect test norms very strongly, even if it's the same demographic group of respondents. So because of things like this, nowadays, people don't really use test norms very much. What we prefer to use are local norms. If you have a sample of at least 50 individuals or so, just calculate a mean and standard deviation in your sample and use this information to interpret individual scores in relation to all other individuals in this particular sample. Of course, if this whole sample is very specific in relation to the general population, you may not know it. But for that, you need to have really good data on standardization, which is usually not available for many research measures. So it's better not to use test norms at all than to use wrong norms. And of course, for research, we don't really need test norms. Just raw scores is enough. So it's actually maybe sometimes a good idea to develop a new measure in your own master's dissertation. If you decide to develop your own measure, these are the steps that you are probably going to take. First, operationalize your construct. Do a theoretical analysis and come up with a clear definition. What it is that you are trying to measure. What are its behavioral manifestations, or what kind of questions you should use. This definition will inform you. The second step is generation of items or tasks. And ideally, this needs to be guided by some kind of theory or some kind of phenomenological data or some kind of expert procedure. And the third step is pilot study, where you administer your tests to a fairly large number of people to analyze the structure and to evaluate reliability of your scales. And at this stage, you may actually discover that you need to maybe add some items because there are not enough to get good reliability. Or maybe you need to correct some item formulations because people don't really understand them. And after pilot, you may actually change your test a little bit and pilot it once again if it does not work as it should. That's why it's best to plan some time for this pilot. It's better not to combine pilot with the main study, because there is a risk that if your test does not work as intended, you will need to do your main study once again. And if your test works as intended, if it has clear structure and it is reliable, you can conduct validity studies, administering it to a smaller sample of people, but who complete a larger bunch of questionnaires, or provide some other data which will help you to evaluate the validity of your test. And of course, in a master's dissertation, this is kind of optional because it's not always possible to validate an instrument. And also sometimes face validity is enough. Sometimes if you translate a foreign instrument, evidence about validity from another culture kind of translates to Russian culture if there are no reasons to expect that it should not work here. So validation, it's good if you can do it, but it's not the most important, because we know that properly validating an instrument takes a lot of time and resources, which we may not have. And the seventh step, standardization, basically involves administering it to a very large sample and getting really good norms. But this is optional because this is very resource consuming. So only for commercial tests, this is typically done. Obviously, for your own instrument, no one will expect you to standardize it. And I don't think I even standardized any of mine properly, because I mainly work with convenience samples. But for research measures, this is totally fine, as long as you're not developing some serious assessment measures like IQ tests. So this was a little bit of overview of psychological measurement and psychometrics. I hope that it was not too confusing and that your brain is not blowing up. There is a lot that you can read. If you are not so familiar with reliability and scales and stuff like this, there are many good books on psychometrics. I propose the book of Paul Klein, The New Psychometrics, but there are also others. In Russian, there is Ferenc Bacharach. And if you're interested in some specific issues like measurement paradigms or psychophysics or construct validation, there are also chapters about it. So this recommended versus supplementary is quite optional depending on your own interests. So I invite you to explore, and I invite you to reflect about your own future instruments. And good luck. Good luck developing your questionnaires. And see you very soon. Next time we'll discuss how we can organize our studies to make good use of the measurements that we conduct. Bye-bye.